What methods do scientists use to study biological origins? Is there a distinctive method of historical scientific inquiry? Meyer set off to investigate not only the history of scientific ideas about the origin of life, but also questions about the definition of science and about how scientists study and reason about ancient events in the past.
What I worked on at Cambridge in my PhD dissertation was the controversy about the origin of life, but also the issue of how do scientists reason about the distant past? Is there a distinctive method of reasoning about the past? Do scientists have different ways of testing their ideas when they're talking about events in the remote past, or even more importantly, the causes of events in the remote past? And this subject came to mind because in the epilogue to Thaxton and Bradley's book, they defended the idea of an intelligent cause as a hypothesis for explaining the origin of life. They defended that idea as something properly scientific because they said scientists of the past have different canons of method. They operate differently than sciences that are trying to describe how nature ordinarily functions. And it seemed like they were onto some kind of an intuitive distinction between saying what nature normally does on an ongoing and regular basis versus saying what happened in nature on a one-off basis, what caused a given event to occur. And so they were making a distinction between two types of sciences, and they were saying that you could invoke an intelligent cause to explain things in the past that was a legitimate type of explanation when you're talking about historical scientific matters. And so I wanted to investigate that more. I wasn't entirely happy with the way they had justified this intuitive distinction, and I wanted to evaluate it and see if it really stood up to close scrutiny as when you looked at the methods that sciences such as evolutionary biology, paleontology, cosmology, archaeology, when you examine those types of fields. So I looked at origin of life studies, origin of life research, the current controversies about what's going on inside the cell and how do you explain it, and also the question, well, how do scientists who are trying to investigate events like that in the remote past, how do they proceed? What are their methods, and how do they make their theories testable, and can they even be tested? I was looking at questions like that.
During his time at Cambridge, Meyer discovered how materialist evolutionists were ruling out intelligent design by trying to define it as unscientific. Modern evolutionary theory was supposedly built on the scientific method, whereas, according to some scientists, intelligent design was not. It wasn't a theory built on the rules and reasoning of science. Meyer discovered that this wasn't the case at all. In fact, the design hypothesis was every bit as much scientific as its competing evolutionary hypothesis, such as chance and natural selection. Meyer began to build a compelling case that it was possible to make an argument for design based on the very methods and rules of scientific reasoning that Darwin, Lyell, and other scientists had pioneered.
Well, one of the things I discovered when I was looking at how scientists reason about the past is that they use a method that's known variously as the method of multiple competing hypotheses, or the method of inferring to the best explanation, inference to the best explanation. And both these methods are comparative. What the scientists are trying to do is they look at the different possible causes that might be responsible for a feature of, for example, a living system or an event in the past, and they say, which of these possible causes would be the best explanation of what we see, what we know happened. And the method of inference to the best explanation raises this question: what constitutes a best explanation? And it turns out that Charles Darwin and his mentor, the great geologist Charles Lyell, pioneered this method, and they had a really practical set of answers to that question: what makes something best? What's a best explanation? What are we looking for? It's a really simple, straightforward, common sense idea, and it's that when we're trying to explain an event in the remote past, we should not invoke exotic causes, the effects of which we've never seen. We shouldn't invent a cause whose powers are unknown. What we should do is posit only causes which are known to have the power to produce the effect in question. So if you're trying to explain the ash layer that descended upon eastern Washington in May of 1980, and maybe you're coming to see this ash layer, you find it many years later, and you say, what caused this event in the past, this collection of ash to land on the Earth? Well, you would want to invoke something like a volcanic eruption, because we know volcanoes can produce ash. You wouldn't invoke the hypothesis of an earthquake or some other kind of a flood or something. Why? Because we know that volcanoes produce ash, and we have never seen earthquakes produce that kind of effect. So a very simple common sense rule of reasoning. Lyell had a colorful way of putting it. He said that we should explain the past by reference to presently acting causes, or causes now in operation. And when I first saw that phrase, it's in the front piece of his great work on historical geology. He says, being an attempt to explain the former things in the history of the Earth by reference to causes now in operation. I asked myself a question. What is the cause now in operation for digital code? What is the cause now in operation for information? And I realized that of course there's only one, and that cause is intelligence, and that suggested to me that it was possible to make an argument for design based on the same method and rules of scientific reasoning that Darwin and Lyell had pioneered. And that was oddly ironic, because one of the legacies of Darwin's work is that he is said to have refuted the design argument, and yet we know, yet I'm convinced that if you apply Darwin's rules of reasoning, he also accepted Lyell's rule that you should invoke presently acting or causes now in operation. He used a Latin phrase for that. That scientists should be looking for vera causa, known causes that are true in the sense that we can verify the effects that they're capable of producing. So the irony for me is that if you apply Darwin's method of reasoning and you try to infer to the best causal explanation of the central feature of life, which is information, is in fact intelligence. So using Darwin's rules of reasoning, you're actually able to resuscitate the design argument and reverse the central legacy of Darwin's scientific treatise, which is said to be the refutation of the argument from design.
Meyer focused his research at Cambridge on three key things: exploring how scientists reason and develop their theories, how scientists use these methods for studying past events such as the origin of the first life, and the history and philosophy of science as it relates to evolution. In this way, he learned how to study past effects in science using the scientific method. And the same mystery that brought him to Cambridge would become the theme and focus of all of his future research.
Right. If you look at an effect and you want to explain it, using the historical scientific method by reference to a cause that is known to produce that effect, the effect in question. So when we're looking at the origin of life, many biologists, biochemists, origin of life researchers in particular say the central thing that we need to explain is the origin of the information that makes life tick, that makes it run. What runs the show in biology is information, much of it encoded digitally in the DNA molecule. We're also learning that there's other forms of information organized hierarchically in other parts of the genome and even beyond the genome. But it's very, I used to ask my students, if you want to give your computer a new functionality, a new function, what do you have to give it? And of course they knew. Code. You have to give it information. And the same thing is true in life. If you want to produce life in the first place, if you want to develop a new form of life from a pre-existing form of life, you have to provide information. And so the question is, where does that information come from?